Right, good morning, Year 8. So today what we are going to be doing is we are going to be looking at evidence from layers, essentially fossils, okay? However, the first thing I would like you to do is go into assignments, and there are some stats questions about the rock cycle. Now, this is really just to consolidate your knowledge about what we did last lesson, okay, about how the rock cycles work, about how you go from igneous to sedimentary to metamorphic rocks, the processes that happen, and the features of each. So you need to pause this video, go into the first sheet, which is called SAT style questions, and have a go at those, and then come back and we'll introduce today's lesson. Okay, so pause the video, do that now, please. Okay, welcome back. So today we are going to be looking at how we get fossils. So the first thing I'd like to do is have a quick go at trying to fill in the blanks in this. So once again, you can pause the video, copy it down, and see if you can fill in the blanks. This is just a quick exercise, shouldn't take you more than a couple of minutes. Okay, so pause it and do it now, please. Okay, so if you were paying attention last lesson about how we get sedimentary rocks, you'll know they form in layers, or they can be formed when water evaporates from the seawater. So if you didn't get these, you can quickly copy these down in just a moment. Now, one of the things that we find pretty much only in sedimentary rocks, but very occasionally in metamorphic, is fossils. Now, this is a bit annoying because I've actually got a really good fossil collection at school. However, hopefully you'll get a chance to see this at the beginning of next year. So, fossils are the mineralized or otherwise preserved remains or traces, such as footprints of animals, plants, and other organisms. Okay, so you see here, in this rock, we've got what appear to be creatures, and if you've ever seen or touched a fossil, you'll realize that these, what look like bones, actually have become stone themselves. They're essentially the same material as the stone which surrounds them. These are very ancient creatures called trilobites, and they're about 500 million years old. So, this is an example of a dinosaur fossil. And if we keep going down, we can look at how we got fossils. Okay, so I'm just going to quickly go through this description with you, and then I'm going to set you about your second task of the day. So, the best conditions for fossilization. Okay, so the quick burial of animal remains in moist sediments. This prevents scavengers from eating and bacteria from decaying them. The quick burial in volcanic ash. So many dinosaurs' bones in America, the American West, have been found buried in volcanic ash. The presence of hard body or plant parts, teeth, bones, shells, wood, for example, unchanging temperature conditions, groundwater that is heavily mineralized, so lots of like salts and dissolved minerals in water. Sediments that are very fine make better burial than coarser gravels, so like sand and silt, and calm conditions so the remains are not broken up by wave or current. Now, when you think about the conditions that are actually needed to make a fossil, you might start to actually realize, actually, it's a miracle that we find any fossils at all. So, your first task. Now, in assignments, there are actually two YouTube videos. I think about 2 and 3 minutes long each. What I would like you to do is quickly watch those, and then I'm going to set you about your next task. Okay, now you can't do this task until you've got the information. So once again, can you pause the video and do that now, please? Okay, Year 8, welcome back. Now, this following part will probably take you between 15 and 20 minutes to complete. What you're going to do is show step by step how you get a fossil actually made. Now, it's talked about molds and casts. They're slightly different, so I'm going to talk you through that in just a moment. But what you need to do is sort of like a comic book, a step-by-step storyboard of how this actually happened. So I took a picture from the internet. You can do the same, or you can draw it in if you're a good artist. And I've just labelled what's going on in the picture very quickly. So dinosaur dies near a riverbed. So a dinosaur dies, it happens near a riverbed, so the body is quickly covered with sediment flowing downriver. This stops it being eaten by scavengers. So I've got an explanation of what's going on. Then I need to move on to step 2. What happens next? So what happens to the bones? And then step by step, how does it happen? Now I've left 8 spaces, so you can go into a lot of detail. You might not need 8 spaces. You might only need 5 or 6. But it should be a step-by-step sort of comic strip, essentially showing how you go from stage 1 to stage 2, stage 2 to stage 3. How is, over millions of years, a fossil actually formed? Okay, so a couple of other little things you need to know. All right, so let's just take the example of this is an ammonite. Okay, so we have lots of examples of this particular species in the fossil record. Okay, and the reason for this is we have a lot of fossils from the sea, because when you think about it, when they die, they sink to the bottom of the sea, and often their shells are covered by sand, silt, and sediment. This happens a lot in the sea, not so much on land. So the land animals' fossil record is a bit more tricky to come by. But let's talk it through. So the kind of steps you're going to need. Death. Having died, the ammonite slowly sinks to the sea floor. Scavengers feed on the fleshy body of the creature, and after only several weeks, all that remains is the shell. Now that might have also happened to our dinosaur. Then, deposition. So, several months after death, the shell gradually becomes covered with silt and sand. These layers continue to build, providing a shield around the shell and protecting it from damage. Time continues to pass and more layers are deposited. A few hundred years, the shell is several feet beneath the surface. Okay, moving on. Time continues to pass, 1,000 years, 10,000 years, more and more. Right, permineralization. Now you'll definitely need this in your storyboard. Gradually, chemicals in the shell undergo a series of changes. As the shell slowly decays, water-infused minerals pass through, replacing chemicals in the shell with rock-like minerals, calcite, iron, and silica. This process is scientifically known as permineralization. Right, so what that means is shells are made from minerals, things like calcium carbonate. We have those in our bones. But if you leave the bones in the rock, those minerals are replaced by minerals from the rock. Okay, it's called permineralization. Essentially, the bone changes into the rock because it's using minerals from the rock. So, over millions of years, the original shell is completely replaced by minerals, and what remains of is a rock-like copy of the original shell. The fossil has the same shape as the original object, but is actually rock. This process also results in loss of its original colour. Over millions of years, the movement of the Earth plate results in the seabed being forced above the surface, and this results in new landscapes within which the ammonite fossil is buried. Once above the surface, the rock is subjected to erosion, and in certain areas of the world, such as Lyme Regis, the rock is once again subjected to the effects of the sea. In these areas, the rock is pounded by the sea, forming towering cliffs. Other factors such as wind, rain, and ice, and the sun contribute to the rate of erosion. And then last couple of steps, exposure. Having laid beneath the surface for 150 million years, the fossil is finally exposed. The final stage may have resulted from a cliff collapse or the effects of paleontologists, and then the fossil can be collected. So, essentially what it's saying is once the fossil is made, geological movements might force the fossil up towards the surface again, where the rock around it is eroded, and that's how we're able to find these fossils. A couple of other examples. Things like fish, sediment, mineralization. Okay, so your task is to produce a storyboard of how fossilization happens. Now, you might need to go back to the YouTube videos, or you might need to just quickly pause the video and refer to certain things I've already shown you. Okay, but I'm looking for really detailed things. So a couple of keywords you are going to absolutely need in there. I'm just going to add them in for you just to the bottom here. These keywords must appear somewhere. Okay. Okay, so there are all the words you need to use at some point in your explanation. So permineralization, and what that is, erosion, sediments, decay, geological movement, mold, karst, although mold and karst, probably you could leave those out if you can't quite work out how to explain them, rock, minerals, bone, and fossil. So, pause the video. In about 20 minutes, you can do it on paper, in your book, or on your computer. This is what I'm after. Off you go, please. Okay, welcome back. Now, just before we finish, next lesson, what we're going to do is we're going to look at what the fossil evidence has actually given us. Okay, I'm just going to very briefly touch on this. So you'll see here, we've got loads of fossils in layers. Okay, and if we go back, we've got very, very early life, things like trilobites, some early fish here, and then we move through amphibians, and then some of the early reptiles, dinosaurs, and then sort of mammoths, and then more modern things like humans at the very top. Now, what we found is that so far, we have never discovered a fossil which is out of place. What I mean by that is, we've never just taken a human skull and found it with with fossils, say, for example, with ancient fish. What we've always found is that fossils are always in essentially the order of the rock that they formed. Okay, so ancient rock always has quite simple, what we think were early creatures. So really simple shelled fish, trilobites, some starfish. Then we think the next layer of ancient rock is fish, and then amphibians. And as the rock gets younger and younger, we find more recent things. So, for example, these were around 250 million years old. Dinosaurs lived about 150 million to about 65 million years ago. They're found in this layer of rock. And then the more recent rock, we find mammals. And then eventually, the most recent rock, we find fossilized humans. Okay, so we have never, ever found a fossil that is out of place. And that's really good evidence for something, okay? It's really good evidence for evolution because it shows us how animals have changed over time. And this is what we are going to be looking at in tomorrow's lesson. Okay, so thinking about everything today, hopefully that all makes sense. Can you please make sure your, I suppose you call it your storyboard, is uploaded for assignment, please? And yeah, good luck, and I'll be online to help if you need.